Welcome to Inventive Engineers channel. Looking in YouTube videos, I found a way to make a spot welder with a microwave oven transformer. The thing is that I want to use this welder for battery assemblies. And what I found is a big problem is that you cannot control the arc, because when you put the switch on, it's almost instantly you blow the nickel tap and you cannot make this. Our addition in this video is I will use this rheostat. This is a variable resistor that I put in series with the primary winding of the transformer, so I can control the arc to make my job. That is going to be welding or soldering the taps for the battery assembly. This way, also we are going to make this spot welder flexible, so we can make also that this same layout is used for conducting here a jaw type of welder to weld bigger pieces. That is going to be achieved by removing our resistance in the primary, and then we will use this for making a bigger arc. The thing is that when we reduce the current, we will find that it's possible to make this spot welding of battery assemblies, which is going to make the whole machine more flexible and easy to use and to have more applications for it. Okay, this is the primary winding. This is the secondary winding. This is a high voltage winding. You have to be careful. If you connect here 127, 220, you're going to have a very high voltage here that is going to be very dangerous for you. We will check how much or how big is the factor that relate both coils. If you invert them, you're going to be in trouble. So let's see first if we have continuity in the primary winding. Yeah, you can see that we have 2 ohms. Then we will check if we have a short to any part of the transformer. Here, nothing. It's open circuit. Here, nothing. So this transformer should be, this winding should be okay. Then we will check the upper. You don't need this coil for anything in our welding machine, spot welding machine. We don't need this. We will remove it. But let's make some tests. We have here, let's check. There we go. And we have here 76, 75 ohms. So this winding is also correct. We cannot check here against the, well, we can check here against the core, but anyway, it is connected here, so it will show the same thing. It will show the same value here, 76, 75 ohms. Okay, so it worked. We will check this later. Now we will prepare this cable for our test. We're going to remove the isolation, the insulator, and we can connect here and plug into the outlet. Let's pull the insulation out. connected to this piece of wood with two terminals. Now we're gonna connect this, that is our part where we're gonna put some voltage in. Okay, let's check with the multimeter. AC volts. Here it is, and we have 123.24. All right. Okay. Now we are gonna connect this here. Here, and this is gonna be here, and the other side is gonna be here. Here, but first we have to, I don't want to have this thing shorted here. I'm going to remove the connection. Let me disconnect this, and we are going to cut this. Now we have here, let's check if we have the voltage here, the voltage we want. Here, let me check it here and here, and we will have 123. Okay, now we will grab from here to this terminal. This is very, very important. Do not do this if you don't know. And we're going to connect the other side of the coil here. This is the high voltage coil, but I'm going to only put 124 volts. So when I grab it here, we have 124 from here to here, right? There you go. I don't know if you can see it. It is there. 122, 123. All right. So now we're going to check what we have in this side that is going to be a much lower voltage. See? We have here 6 volts. I don't know if you can check that, but it is 6 volts. Okay, there are 6 volts there. 5, 6, 5, 6. All right. So we can establish a relation between the primary and secondary winding of this transformer. Now, with the data obtained in the transformer turn rate, we have the voltage in the top that it was 123 volts divided by 6 volts in the voltage of the bottom coil. We can have the turn ratio. The turn ratio is 20.5. With that number, we can now try to define which is going to be the voltage that we will obtain under normal circumstances if we put the voltage in the bottom coil of 123
bolts and how much we are going to have in the top coil, the voltage of the top coil. So if we have the equation correctly set, this voltage in the top coil, it will be 20.5 times the voltage in the bottom coil. So 20.5 times 123. How much is this gonna be? We take the calculator, we put 20.5, the turn ratio, by how many times? 123, and we will have the voltage. 2,521.5 volts. So this is a very, very dangerous voltage that we are gonna have. We're gonna write it here. Very dangerous voltage.
Well, in the title of the video, we said that we are making a homemade spot welder with a microwave oven transformer with a control. This arc control is achieved by a resistance, because we want to make a welding with a small tab here, that we try to make a battery assembly with this. The problem is that when we have this connected and we want to make the arc, is so quickly that it burns, and let's see, it cuts the piece here. So it is so hard, the arc, that we are not able to control it. We are gonna find with a rheostat what is the right size of that rheostat, so you can control for these smaller works for your spot welder. So you will be able to make battery assemblies with your same spot welder. We will tell you how. We are adding value to this video by showing you how to use this resistance to control the primary current and the primary winding of your microwave transformer, so you control the arc and the secondary to achieve a less current, so you can solve these tabs that is the normal size that we use for battery assemblies. The value of this resistance is around 12 ohms. For this transformer you have to check, and if you would like to have a stronger arc, you remove the resistance and you can do with your welder a bigger, stronger job. Let me hold this and I can show you this. So it's around 11, 12, 13 ohms. So now it can reduce the current, so we can do this. I show you when it burned everything up, and now we are gonna be able to do this welding. There we go. There it is. And this way we achieve a much stronger and let's say a less arc, but a very strong bond, a very strong weld. So this is the way that we control the arc, and then you can remove the resistance to make bigger jobs. is our final layout for the machine. We can see the jaws here for welding bigger pieces. When you do that, you must remove the resistance from the primary winding. This is, for giving the whole power to the machine. So you shorten here, you have no resistance, and directly to the switch. We can use this machine for this type of welding, and we can install this for small pieces, for battery assemblies. You can see that this Nylamid holder is for holding the electrodes apart and also keep them very close together to make it very good and fine work. Okay, so let's try with this nail. And you can see that the piece is very hot, but it's held together now. Wow. Okay.